right, everybody, welcome to the Distilled Buildings Technology Podcast.
Where smart buildings are shaken, stirred, and data-driven.
I'm your host, Jason Shear.
I'm your host, AK.
And welcome to the show. So what is in your glass today, AK?
I have the Michter's rye.
Yep, Michter's is a solid choice for sure. Just
how about you?
on the rocks or neat?
On the rocks and our favorite logo.
Excellent. Good deal.
How about yourself? What do you got?
So I'm obviously a huge bourbon fan. Love rye. Have been on an old fashioned kick, but I've found this like fast old fashioned recipe. Where you don't have to use a mixing glass or anything like that. You can mix it right in your rocks glass. So I just put a big rock in there. Pour some rye whiskey, and then a little bit of simple syrup. And I found chocolate bitters, like cocoa bitters, are just a really, really good complement. And then instead of, getting a peeler out and, an orange, I have just been using these dehydrated orange wheels, and it makes a really, really nice looking cocktail.
That just sounds delicious. Okay, just pour the rye into a glass.
Pour the rye into the glass with some ice and you're good to go.
That's it. Cheers.
Cheers. And I found this brewery out of Louisville, Kentucky, Rabbit Hole. I'm drinking their Boxer Grail rye today. But it's, like we see with a lot of distilleries, great couple of people that started it and just like a really, really good story around that. So I'm really tempted to go on like a bourbon trail trip one of these years. So we need to talk about that.
That's definitely in the works. And definitely we're going to try to do it. Yeah, I mean, obviously I go for the bourbon, but the rye, it just, there's a taste sometimes, and that's just trying to have some rye, and at Michter's, you can't really go wrong.
Nope, can't go wrong. And this is this Rabbit Hole is, it's 95 proof, but it's like a 95% rye, 5% malted barley. So it definitely has a really, really good rye spice to it, similar to a Bullet or something like that.
Yeah, mix it up.
Cool. So I think off to the episode. So today we are having a chat with Mahmoud Ibrahim. He is a senior product director at Panduit on their fault managed power product. And this was previously recorded like live in Chicago at Panduit's headquarters. So enjoy the conversation.
That's going to be a lot of fun.
I'll let you intro that part. Yeah. We're Panduit Innovation Center. Yeah. Cool. Well, so this week we're with Mahmoud here at the Panduit Innovation Center in Tinley Park. We're doing some some enablement, some training around FMP or fault managed power. So Mahmoud, do you want to tell us like a little bit about yourself and what you do at Panduit?
Yeah, absolutely. First, it's actually a pleasure to have you guys here visiting, hosting you. So my background is mechanical engineering. I graduated with a PhD focused more on heat transfer fluid dynamics, so I had nothing to do with electricity for a while. Wow. That's what I did at Panduit in R&D, and then the past 4 or 5 years I've been involved in fault managed power, wearing many hats. So started off doing business development to figure out the product, where it's going to fit, doing a little bit of product management, now marketing, selling. So it's kind of like a startup within Panduit, so jack of all trades pretty much.
That's awesome. How'd you make like the leap? I'm always interested in like career arcs, like mechanical engineering, and that's what I studied as well. Like how did you end up from mechanical engineering to like electrical product management?
I always wanted to be more on the business side of things. I knew that eventually I'm going to get there. And it's just opportunities within Panduit. That's actually a nice thing about the company is things open up. So I started doing more business development things, like coming from an engineering angle, and I've always been interested in doing my MBA, so got that done about a year ago now. Through Booth. It was a fantastic experience, and so now I've kind of jumped over to the dark side.
That's awesome. Tell us in your world, what's FMP or what's fault managed power to the audience that doesn't know that?
Sure. Sorry, I've been probably using the acronym.
We're used to it. Yeah.
So fault managed power, it's like you, Jason, had said before, it's making dumb power smart. I really like that phrase.
TM. We're all going to get like royalty checks for that.
But it really, that's really a big part of what it is. It's the way we run electricity today. It's just, I've not really been exposed to running circuits and working with electrical circuits in the past. But just think about how it's done in our homes. You have to run cable through conduit, you have outlets, you have electricians installing that, you have breaker panels to deal with. That's the traditional. Fault managed power is coming in to kind of disrupt that a little bit, where it's allowing you to deliver higher voltages over thinner copper gauges. You can go long distances, but the fault managed piece is it's actually constantly looking at the circuit to see if there is an actual fault or something that can cause a hazard like a fire or a shock to someone dealing with it. And if it does, then it just, the fault managed piece just turns that circuit off. So it's a very smart, you can think of it like a smart circuit breaker that can detect multiple types of fault, just basically making electricity safe.
It sounds kind of like an extension to like a lot of us in our homes, we have those GFCI breakers in our bathrooms. It's kind of like an evolution or like GFCI on steroids.
Absolutely. Yeah, so if you think of a fault managed power system, GFCI, it detects, that's like a ground fault, it's called. It will detect that, but it'll detect a series of 6 or 7 other faults, like arcs, and going down to someone actually touching the cable that has higher voltages. We're talking like 300, 400, 500 volts here. Oh, wow. Detect and turn off.
Fascinating. And this technology has standards and regulations at this time?
Yes, it does. It's UL published a standard called 1400-1. So they call it fault managed power systems. It's a mouthful, but that was published, let's say, 2 years ago now, maybe even 3. And it basically looks at, to develop a system to be safe, to be fault managed, you have to adhere to different types of faults that you need to detect, how quickly you need to detect them and turn off. There's a whole series of tests that you have to go through with UL to get that done, which is pretty comprehensive. So usually when you do this testing, it's like you got a system, usually it's like a transmitter on one side, a receiver with a cable in between, and that's the full system. And there's about 500 tests per cable that you have to go through and do to make sure that that system actually works and is safe. So that standard covers these faults, covers how fast you need to detect, but it also has other things like AMC, AMI conducted and radiated emissions that need to be tested for. It's tested for IT safety. There's a common standard, IEC 62368, which most equipment get tested to today. They go all the way out to the manufacturing side as well. So making sure that you have processing in place when your system comes out from production, it's been tested to all the faults to make sure that it actually is safe. That's on the system. And then there's 1400-2, which is for the cable. And essentially the biggest thing about the cables for these systems is they need to be 450 volts rated. Typically, if you look at category cables, low voltage, they're like in the 300 volt range. Now there's a standard that's covering 450 volt rated cables.
Got it. So it's very different cable than like your regular like Cat6 structured cable that you use for PoE or Ethernet.
Correct. Yeah. Usually you'll see multi-copper pair in one cable, and the sweet spot is like within buildings, 16 and 18 gauge. If you go outside, it's minimum, I'd say 16 and then 14 or even 12.
Got it. But even within that jacket, there will be, it does look like it's twisted. Yes. So kind of taking some of the same concepts from like the Ethernet and structured cabling side, and there'll be multi-conductors like inside of a jacket.
Yes, and the twisting is not a requirement, but systems do perform better with them because it's not just power going over the cable, there is some minimal communication happening between the transmitter and the receiver side. And it also, because the cables are going to come in with multi-pairs, so when you work with multi-pair cable, it's just much easier if they're twisted, so you know which pair goes with which on both sides.
Okay.
Once you get to like 3, 4, sometimes you can get up to 16 pairs now. You need to twisting so you know which pairs go together.
Got it.
Typical color coding on RJ45.
Excellent.
And what are the verticals that you see this technology tackling first?
So we see it I'll just take a step back and say, we think this is kind of like the evolution of power delivery. And eventually, if we look at where standards and codes are today, it's focused more on commercial. There's work being done right now for the 2026 code to turn this into multi-dwelling units as well. And then I can foresee in the future this also going into residential. So eventually we think it can cover a lot of applications. It can power a building, maybe not quite there for like chillers, air handling units, the big loads, elevators, etc. But for the most part, covered most applications. And so you can think of that as it can go across multiple verticals. The ones where we're seeing some traction in today, I would say, are outdoor deployments in general. And I'm going to talk maybe application, like a security application, or enabling Wi-Fi outdoors, or cameras, etc. That's a very key or common application. So when you look at verticals, this is across all verticals. This is campus environment for K through 12 or universities or hospitals or manufacturing facilities, really across all. If we talk more vertical specific, I want to say K through 12. There's a compelling use case for, because you can think of a school being very compartmentalized. It's very similar, it's a classroom structure. They got a couple of lights, a Wi-Fi access point, camera that can easily be powered back from a fault managed power system like Panduit's, feeding probably like a switch from Cisco, and then PoE to the kind of like the branches to the camera, to the cameras, to the lights, etc.
That's interesting. So PoE and fault managed power, like they're very complementary.
Absolutely. Yeah. We get that question. We get asked that a lot. Is this like the replacement of PoE? No, it's not. It's kind of like, I think of it as the FMP or fault managed power is the tranche, and at PoE is the branches. So you have to have the main trunk feeding in. That's the main power from FMP, and then PoE does to the end devices. You'll need PoE because devices don't consume that much power, but they need the data. So I would say PoE is focused on the data with a little bit of power. FMP is focused on the power with a little bit of data just for intelligence and safety and monitoring, etc.
Got it. Very cool.
Now, if I go back to other applications, so we start by saying it fits across the board for all applications, but today a lot of end users, they want to see an application. You can't just tell them, it can do everything. So we try to be very specific. So I mentioned security, lighting, enterprise building switches, and DAS, or in-building wireless networks. Those are kind of like the four main ones that it's easy for people to gravitate or understand the value proposition, how to install it, how to maintain it, etc.
On the installation side, so that's another thing that we've heard a lot about. Does it require certified electricians? Because it feels like it's sort of between structured cabling technician and electrician. Like, which side does it fall on?
That's a great question.
Is it a loaded question?
It is a loaded question. And you know it. We're kind of trying to figure out our way through that too. I think everyone has learned some lessons when PoE came around, because that question was around then. But I'll start by saying this. The technology can be installed by anyone, and the value is still there, whether it's an electrician or a low voltage contractor, because you're basically deploying more efficient power, more safe power, quicker. So it doesn't matter who's installing it, you'll just be able to do it quicker. Because one of the values that probably we didn't touch on is, because now it's safe power, you can install it like you do a category or a low voltage cable. So you can run the cable for FMP in the same pathway as your fiber or as your data cable. You don't have to run it in conduit. And that's part of the big savings, like day one on the installation side. Kind of going back to like like a school environment, the school only if they're doing like retrofits or changes, they only have really spring break or have the summer to make changes. So this solution gives them an easy way to run cable, get installed, run power without having to put a bunch of conduit and bending pipes, etc. Now, whoever did that, whether it's an electrician or low voltage, the value is still there.
Oh yeah.
So, but going back to your question, we're seeing Mika taking actually a pretty positive attitude towards this by first restructuring the National Electrical Code, and that's going to happen for 2026, where they're going to introduce in Chapter 7 what's called a limited energy. Like they're going to bundle POE, Class 2, FMP, or Class 4 all under limited energy, and then start coming up with limited energy certifications for different states, so that now you can have a low voltage installer get a limited energy certification to install the same thing as an electrician. There's going to be some pushback in some regions, of course, that are heavy on conduit and union, as like New York City, Chicago. But we say the value is still there. Even if you're going to run conduit, just put the fiber and the copper together in the conduit, and the savings are still compelling.
You mentioned in the topology transmitter and receiver. Is that today interoperable? You can switch between the two? Are we there yet?
Not there yet. We're like at the infancy of this. And I'll just kind of mention the Fault Managed Power Alliance, because the whole goal behind Panduit, behind Cisco and other players involved in this space, we founded an alliance to really push market traction in market adoption of the technology. Eventually, for this to really be mass kind of market, it needs to be interoperable. But I don't think the technology is matured enough that you can have just a standard way of doing this, and that's how everyone goes by. There's work being done towards that. I think it's going to take some years to get there.
And that alliance, like a lot of your competitors are in that space, they're in that alliance as well, right?
Yeah. So the founding members of the alliance are Panduit, Cisco, VoltServer, Belden, and Prismian. And honestly, we all need to work together to promote safe, efficient power. That's the end goal. And if we can promote it collectively together, it's just going to be better for everyone. So we're hoping to attract even more bigger players in the market to the alliance as well, to kind of have the same objective.
And it's no different than the POE consortium that we're on. It's a lot of competitors that are trying to move the market forward. And even now with some of the conversations we're having with the FMP Alliance and the POE consortium to drive observers, that maybe cross-membership could be a viable solution, which I think it's great for the market, because it just makes the adoption much easier.
I'm actually curious, like for the POE consortium, have you has that been of value over the years? Have you seen promoting of POE be better? Can you talk a little
Absolutely.
bit?
Yeah, it's right at the start. The founding members decided that the idea of a technology that's driven by one player, it's never going to move the industry. And the ability to have multiple players in one room deciding about the standards, the technical committees, the trainings, allows that collaboration. It also moves the market, because now the clients and the consumers are not thinking this is a one product that it might or might not be around. Once you start having an ecosystem with partners and competitors, you now have an actual ecosystem that you can push forward.
Yeah, and I think that when we think about the POE consortium, it's going to be very IEEE focused. And the FMP consortium is going to be very, NEC and IEC focused. I think in a perfect marriage, like having both of those come together, and maybe we'll see an IEEE standard for the communication protocol over FMP someday in the future.
It probably has to go through IEEE for interoperability. Eventually.
Cool.
Maybe a 3 to 5 year, you close your eyes and we're in 5 year mark, what happens? Where are we going to be?
You're going to see a lot more FMP deployments in more and more applications. So I think our approach today is, even though we think it can be across a building, It's to be very focused on specific applications and then provide the value to the end users there, show success stories there, and then kind of move on. So between lighting, security, enterprise building switches, and then eventually 5 years from now, there's enough deployments around many of these applications that you've basically covered most of your building. And so now you have consultants, end users already looking at new builds that are with fault managed power specified in as kind of like the main power distribution, whereas maybe you still have some AC circuits for, again, your chillers, your air handling, that kind of thing. So hopefully 5 years, that's where we'll see things. The technology is also going to evolve where you're going to have more and more power. I mean, right now it's, like our solution is at 600 watts per copper pair. You can guarantee that you'll start seeing more and more power over the years, and being able to cover applications like data centers and electric vehicle charging. Because the technology is there, you're allowed to, there's no limit on the standard. It says you can do 450 volts, no limit on the power. It's energy limited, so you can push as much power as you want across the cable as long as you know how to detect it and turn it off and make it safe. So I think that's what's going to happen too.
That's a pretty big differentiator versus like the other classes of power as the NEC defines it, right? Like class 2, like PoE, like we know that we've sort of hit the end of the road with 90 or 100 watts and 60 volts.
Yeah.
But class 4 does not necessarily have that wattage limitation.
It doesn't. So class 2 or PoE is considered a power limited circuit because it's defined both the wattage and the voltage. With FMP, it's defined voltage, no limit on the wattage. It's limited energy. And the energy piece really comes in like, if you think 450 volts, just rough numbers, if I'm pushing 1 amp, that's about 450 watts. And it's how long someone gets exposed to that when they touch the cable. So if I touch the cable, I'm getting exposed to 450 watts. How long can I get exposed to it before I get harmed? That's what basically the standard covers. And obviously the more power, the faster you need to turn off to limit the energy. So,
yeah.
I was exposed to touching FMP, and I think you mentioned it earlier, is the placebo of thinking about it originally. And as soon as you touch it, knowing that you're going to get some zap, yes, you might feel a little bit. But talk about how safe is it, and the aspect of you can actually physically touch it and not feel anything.
You're still here.
I'm still here. I've been touching it for a while now.
Yeah.
And so I don't like the term touch safe because it's misleading. Because definitely if you touch the circuit, you're gonna feel something, but it's not going to harm you. It's not going to start a fire or cause any issues. And it really is very different between different people. Like, we're all resistors. Once you touch that cable, you're a resistor in that circuit. And we have very different resistance values.
Sure.
Even like the humidity level, this salt, and it's just everything can affect how you feel that the pulse. So what I've noticed is kind of like to your point, when I anticipate touching it, it's the worst feeling, even though it's not that bad. But when I'm working with the cable or the system and I accidentally touch it, it's like, I just felt it. So it's pretty minimal if you're not paying attention, and if you're anticipating it, I think just the anticipation makes it worse. But again, it doesn't harm you, it doesn't hurt them.
And like being arc safe, so like whenever, like if you have a short, like a line to line, like there's no arc.
No arc.
So there are probably other like industries or verticals where like an arc safe power solution could be beneficial, like high oxygen in healthcare, or like industrial and manufacturing where you have, hazmat or mining. Like those are the three that always come to mind for me.
Yeah, I mean, the potential really is huge. Mining is, I know you mentioned it earlier, and we've seen some interest in that space as well, especially because of the environment, the long distances, how quickly they need to get things up and running, the troubleshooting aspect of things, not having to send someone out to reboot a switch or a device. But yeah, we're really just kind of scratching the surface with fault managed power. So definitely, because of the lack of arc, it's helpful in these types of environments because it's safer.
Yeah, if we look at most of fires now, they're generated out of plenums because of electrical circuits. And if we can eliminate that, it's really, really good.
Cool. Anything else you want to leave with folks before we wrap up?
No, I just want to say thank you for having me. This was awesome, and it's been great hosting you guys here as well. We're kind of on this journey together. I want to actually give a plug to Cisco because when we go out and talk and promote full managed power, it's better to do it collectively as an industry. And I think you guys put together kind of an alliance program that we're all part of now, which it helps with the end user story to see that you have Cisco, Panduit, MHT, FinLabs, and other companies that can fill in all the applications that you need in the building. It's not people kind of working in a vacuum and consultants or end users have to figure out how to do things. So I think that's a great thing, and let's kind of just keep driving this forward together, and hopefully we do another one of these in a couple of years, and we have a lot more deployments of FMP by then.
Awesome. Awesome. Thanks, Mahmoud.
Thank you, Mahmoud.
Thank you, guys.
It's a pleasure.